Use the upper sum u6 for the integral from 1 to 2.5 of 1 on t dt to show that e is greater than 2.5. It says to use the upper sum u6, so let's calculate it. First I'll write down the formula. un is equal to delta x times the sum from I equals 1 to n of capital Mi, where delta x is the width of each subinterval and capital Mi is the maximum value of my function on subinterval number I. Okay, and we're doing u6, so it will actually be 6 here and 6 here. Excellent. Now, is there anything else I need to say there? Yes, I've mentioned subintervals here, but I haven't told my reader what the subintervals are, so I should put that up here. Divide the interval I'm integrating over, which is 1 to 2.5, into 6 subintervals. So let's read this out. Divide the interval from 1 to 2.5 into 6 subintervals, then u6 is equal to delta x times the sum from I equals 1 to 6 of capital Mi, where delta x is the width of each subinterval, and capital Mi is the maximum value of the function on subinterval number I. Okay, so let's figure out what these things are. First, delta x. So delta x would be the width of my big subinterval divided by 6, because I'm cutting it into 6 pieces. So that would be top minus bottom. That's the width of my big interval divided by 6, which is 1.5 divided by 6, which is 0.25. And so now I can know what my subintervals are as well. My first subinterval starts at 1 and goes up to 1.25. Let me just write down all the endpoints of the subintervals. Subinterval endpoints are, the first subinterval starts at 1 and goes 1 plus delta x, so that would be 1.25. And then I would go another delta x, so that would be 1.5, and then 1.75, and then 2, and then 2.25, and then 2.5. So they're my 6 intervals with 7 endpoints. So next I need to know where the maximum is on each interval, so I have to calculate capital Mi, and my function is 1 on t, which is decreasing. So the maximum happens on the left hand side every time. Let me start a new page to say that. Since 1 on t is decreasing, Mi occurs on left hand side of each subinterval. So therefore it would be 1 over that left hand endpoint. So therefore u6 will be delta x, which was 0.25, times the sum of the mi's. So it'll be 1 over the left hand end of each of the subintervals, so that would be 1 over 1 plus 1 over 1.25 plus 1 over 1.5 plus 1 over 1.75 plus 1 over 2 plus 1 over 2.25, and that comes out to 0.25 times 3.9825 approximately, and that's equal to 0.9956. Great, so I've figured out U6. How does that help me decide whether 2.5 is more or less than E? Well, I can at least decide how U6 is related to my integral. I know that the integral from 1 to 2.5 of 1 on t dt has to be less than the upper sum. So that's less than U6. And so therefore the integral from 1 to 2.5 of 1 on t dt is less than 0.9956, which interestingly is less than 1. So perhaps I should look up what the definition of E is, and this will help me to actually figure out why this is useful. E is defined to be the unique number such that ln E is 1. And ln E is the integral from 1 to E, so E is the unique number such that the integral from 1 to E of 1 on t dt is 1. Now, the integral from 1 to 2.5 of 1 on t dt was 0.9956, so that's less than 1. So, since the integral from 1 to 2.5 of 1 on t dt is less than 1, 2.5 must be less than E. Let me draw a diagram of that to just see what's going on here. There's 1 on t, and there's 1, and here's 2.5, and the area here from 1 to 2.5 was less than 1, and so since the area from 1 to E is 1, it must be further out to get a bigger area. So E must be over here somewhere, so that when we add this little extra bit, we get a bigger area. Excellent. That's the end of the problem.